Right, we're doing more recursive graphics. So I've written this program called Koch Snowflake. We'll discuss what that is in a second. But it's very simple, and I'm sure you know exactly what it will do. I create a canvas. I draw a line from 0.5, so that's in the middle on the left, to 1.5, that's in the middle on the right. So if we run this, we should see a straight line going from left to right, and we do. This is not recursive, obviously, but what we want to do is to turn this straight line into a bendy line, like this. So I want to turn a straight line into a line that goes 1/3 of the way, then turn 60 degrees, go 1/3 of the way, turn 120, go 1/3, turn back 60 degrees and go the last third. This will form an equilateral triangle. Interior angles are 60 degrees each. And so I know that the length of this side and this missing side are all exactly the same, and it's 1/3 of the total length. I don't need recursion for that either, but what I do want to use recursion for is when I draw this first third. Now I want to turn this straight line into a bendy line as well. Going a third, a third, a third, a third. And then I want to turn this first third of this first third into a bendy line as well. And that's where the recursion comes in. I'm going to recursively draw lines. At the first level of recursion, it will just be a straight line. So that's my termination condition. If my n parameter is 0, I'm just going to draw a straight line like that. Now, we can do this with standard draw, but it'll be easier if we can just have commands that go forward in a certain direction and then turn. And then go forward and turn. So I want two commands, a forward command and a turn command. And I'm going to write it using standard draw, and we are going to write that now. So let's see, I have the code hidden here. Right, let's look through this code. There are global variables x and y, which is the current position I'm at, and an angle that I'm facing. I wrote a function or method called turn, which simply adds angle, the parameter, to the current angle. So it turns to face in a new direction. And then I have draw line, which looks a little complicated, but it's not really. I have my current position x and y, and then I calculate a new x and a new y using these formulas. So if you think about these formulas, I'm going a certain length. I add cosine of my current angle times the length to x, and the same for y. So I'm basically doing this. I'm at x and y, and I'm facing angle A, so I'm facing up to the right. And I want to move forward to position nx and y. So to x I add size times the cosine of A, and to y I add size times the sine of A. That's all I'm doing here. Calculating the new x and the new y, drawing a line from my current position to nx and y, and then I set nx and y to my current position, so I've effectively moved from here to here, and I drew a line. So once again, this is still not recursive, but it's the first step. So I'm going to replace my old code with draw line 1, which is the width of the canvas. And you can see I start out at x0, y half. So that's in the middle of the canvas on the left. And this should be doing the same as I did before. Save and run. Right, so it starts off, this is my starting position. A is 0, so I'm facing due east. And then I just draw line 1, and it calculated the new x and new y, drew the line and moved there. So now my pointer, or cursor if you think of it like that, is over here. Right, And now I want to change this draw line command so that it recursively draws these spikes in the line, turns a straight line into a bendy line. So I'm going to call that something else. I'll call it Koch. And I'll get to that in a second, but I need to know the depth of the recursion and also the size or the distance I want to travel. And as I said before, if n is equal to 0, then I just want to draw a straight line that is distance long. But otherwise, I want to draw a line that goes 1/3. So I'm going to call Koch n-1 dist. Then I want to turn, let's see, I want to turn 60 degrees, draw another segment like that. I want to turn, I want to turn the other way 120 degrees, draw another line segment, and lastly I want to turn back and draw the last third. So I'm calling Koch, or Koch calls itself 4 times. 1, 2, 3, and 4 to draw the 4 parts of my bendy line. And if n is 1, then this will simply draw Koch 0 dist. So but I shouldn't be going the whole distance, it should be 1/3. Why didn't you tell me? Okay, right. So easy to make a mistake. Right. Draw a straight line of level n-1 for 1/3, and if n is 1, then n-1 is 0, and this will simply draw a straight line. Of course, if n starts off with 0, it will always just draw a straight line. So let's see if this works. Koch 0, and I expect a straight line. Now it complains I haven't put the distance, it should be 1 for the straight line. And straight line as we expected. Okay, let's make this Koch 1. Excellent, that's exactly what I want. So let's just revise. I call Koch 1 with distance 1. So I'm telling it draw a straight line from this point to there of distance 1, that's 1. The width of my canvas, let's just fit all of it in. But because I pass a 1, it won't really draw a straight line. It'll come here and draw a Koch 0 line for 1/3 of the distance. It'll turn, it'll draw another Koch line, Koch 0 line for this 1/3 of the distance, turn, line, turn, line. And you can imagine if I make n bigger, I expect more of these spikes to appear. There we go. So it drew this first part by calling itself, and that caused that line. Then it turned through that part, turned through that part, turned through that part. And as you can imagine, I can make this bigger and bigger, causing more and more recursion. And this curve that I get is known as Koch's curve, or sometimes Koch's snowflake. If you put 3 of them together in a, in fact, we can easily put 3 of them together in a triangle. It won't be perfect because I start off on the side, but let's try that. Let's say I want to go 0.7 of the distance, and then I want to turn on the outside of the triangle, so that's 120, and I draw another straight line, and I do that again. So these are the 3 sides of my triangle, and if I turn this into a 1, sorry, a 0, you'll see that I'm actually drawing a triangle. Now I'm just drawing straight lines. So, see, it's 0.7 is too much. I'll make some other changes just now. So I drew a straight line, turned 120 to face this way, drew a straight line, turned 120, and drew the last straight line. But let's just reposition the, so I guess I want to make that 0.2 and 0.2. I think this should be fine. Right, almost in the middle. And now to get Koch's Snowflake, I'm going to call this with, let's say, a 5 and a 5 and a 5. And, ooh, okay, that doesn't look much like a snowflake. Oh, because it's turning the wrong way. It's drawing the lines the wrong way. I wonder if I do a -1 if it'll work. No, this is just experimentation. But I think it might just work with negative numbers. No, oh, it can work. It can work. I should just turn 60 degrees, I guess. 60 degrees. I think this should work. Kind of going in reverse now, so I should okay, that didn't work at all. Okay, one last try. If it's not, maybe it's 240. Because 240 is -60. No, it's not. No, forget I said that. But it did work. So we get this roughly snowflakey-like curve that was first described by a Swedish mathematician called Koch. Okay, right. That's one piece of recursive graphics.